Imagine a world where cities can think, learn, and evolve, where traffic moves smoothly, lights adjust to save energy, and water reaches every home with precision. This isn't the distant future, it's happening now. Welcome to the era of AI city brains, where artificial intelligence transforms urban life into a living, breathing network of intelligence. Hello, welcome to Civil Engineering Edge. In this video, we'll explore how these digital minds are reshaping our infrastructure, optimizing resources, and redefining what it means to build a city. The future of civil engineering isn't coming, it's already here. Background music builds, futuristic city lights, AI data visuals, drones scanning streets, smart traffic systems in motion. Imagine a city where traffic jams are a distant memory, where energy is used wisely, and where every system, from water supply to emergency response, works in perfect harmony. What if I told you this isn't a distant dream, but something already being built today? Welcome to the age of AI city brains, the invisible, intelligent networks that are reshaping the very foundations of urban life. In this video, we'll explore how artificial intelligence, combined with modern engineering and data systems, is transforming ordinary cities into responsive, adaptive, and self-learning organisms. So, let us dive deep into how our cities are evolving and how civil engineers are at the center of this incredible transformation. The dawn of intelligent cities. Cities have always evolved in response to human needs, from the ancient walled towns that provided protection to the industrial age metropolises that powered economies. But today, cities are entering a new phase, a phase where they can actually think, learn, and adapt. This is the birth of the intelligent city, a living ecosystem powered by what experts call the city brain. At its core, a city brain is an AI-driven system that collects data from millions of sensors, cameras, and devices spread throughout the city. It processes that data in real time, allowing the city to monitor itself and make decisions without human delay. Think of it as the nervous system of an urban environment, with roads, bridges, utilities, and buildings acting as its organs and data as its lifeblood. What makes this concept revolutionary is its ability to connect every infrastructure element into a single learning network. Roads are no longer just physical structures. They're digital platforms that can sense congestion and adjust signals automatically. Buildings can monitor their own energy consumption and communicate directly with power grids. Water pipelines can detect leaks and send maintenance alerts instantly. For civil engineers, this is a massive shift. Design no longer ends at construction. It extends into the digital realm, where AI helps maintain, optimize, and even predict the future behavior of structures. The dawn of intelligent cities signifies the start of a truly adaptive era in human civilization, where urban spaces evolve with us, learning, reacting, and constantly improving our quality of life. From smart grids to true urban intelligence, the journey toward intelligent cities began with something simple: the smart grid. In the early 2000s, engineers and city planners started experimenting with systems that could automatically adjust electricity flow based on real-time demand. This was one of the first examples of machine-assisted urban management, and it laid the foundation for everything that followed. As technology advanced, new layers of intelligence were added. Smart traffic lights began adjusting based on congestion data. Public transport systems were equipped with GPS-based monitoring. Surveillance networks could track movement patterns across the city. These systems were impressive, but they operated in isolation, each solving a single problem without communicating with the rest. The true breakthrough came when artificial intelligence entered the picture. Suddenly, these systems could share data, learn from one another, and coordinate actions across multiple domains. That's when the concept of the city brain emerged, not as a collection of smart systems, but as a unified, self-learning entity. A real-world example of this evolution is Hangzhou City Brain in China, developed by Alibaba Cloud. It processes petabytes of urban data every day, controlling thousands of intersections, optimizing bus routes, predicting traffic jams, and even helping emergency vehicles reach accident sites faster. Reports show that travel times have dropped by up to 15%, and emergency response efficiency has improved dramatically. Now imagine applying this intelligence to every aspect of civil infrastructure: bridges that self-monitor, drainage systems that anticipate floods, and construction projects that simulate environmental impacts before breaking ground. This is the future of engineering. The transition from smart cities to intelligent cities represents not just technological progress, but a complete redefinition of how cities think and interact with their inhabitants. A true leap toward autonomous urban ecosystems. Why now? The convergence of AI, IoT, and ubiquitous connectivity. For decades, urban planners and engineers dreamed of fully connected, responsive cities. So why is this vision becoming reality now? The answer lies in the convergence of three powerful forces: artificial intelligence, AI, the Internet of Things, IoT, and ubiquitous high-speed connectivity through 5G and cloud computing. AI provides the brain power, analyzing vast streams of data, learning patterns, and making decisions in real time. IoT supplies the senses, millions of sensors embedded in roads, bridges, and buildings constantly monitor temperature, vibration, energy use, traffic density, and air quality. Connectivity acts as the nervous system, transmitting this information instantaneously, ensuring that the entire urban network functions as one coordinated entity. With these technologies working together, a city becomes self-aware. It doesn't just collect data, it understands and acts upon it. If a traffic accident occurs, the AI city brain can automatically rear out vehicles, dispatch ambulances, and even adjust nearby traffic lights to clear the path. During a power outage, smart grids can redirect energy from other zones in seconds. Water networks can predict pressure drops and prevent leaks before they happen. For civil engineers, this technological harmony is transforming every stage of design and operation. Using real-time data and digital twins, engineers can simulate infrastructure performance under different conditions, earthquakes, floods, or peak traffic, and optimize designs before construction begins. The rapid growth of cloud computing and edge AI also means data can be processed locally, reducing delays and improving responsiveness. Combined with sustainable design principles, this ensures cities are not only efficient, but also resilient and environmentally responsible. In short, the reason now is the age of AI city brains is because we finally have the perfect combination: intelligence, connectivity, and data integration, working together to make the dream of self-managing, predictive, and adaptive cities a tangible reality. Anatomy of a digital metropolis, sensors everywhere. How millions of data points are collected from traffic to trash, visuals, aerial city time-lapse with glowing data streams. Close-ups of sensors on street lights, bridges, and vehicles. To understand how an AI city brain works, we need to start with its foundation: data. Every intelligent decision the system makes begins with observation. And in a digital metropolis, observation happens everywhere, all the time. Across the entire city, millions of sensors act as digital eyes and ears. Traffic cameras, GPS-enabled vehicles, environmental monitors, and smart street lights constantly collect information, measuring speed, air quality, humidity, temperature, and even pedestrian movement. Every intersection, parking lot, and highway becomes a data source. Waste bins are now equipped with fill-level sensors, notifying the system when they're almost full so garbage trucks can plan optimal collection routes. Water pipelines carry smart flow meters that detect pressure drops, early signs of leaks or blockages. Bridges and buildings are embedded with vibration sensors that continuously assess structural health, sending early warnings to engineers before visible cracks appear. These sensors are connected through IoT Internet of Things networks, transmitting data wirelessly to centralized cloud servers or edge computing units. What once required manual inspection or lengthy reports is now updated in real time, a continuous feedback loop between the physical and digital worlds. But collecting data is only half the story. The true strength of the AI city brain lies in how it integrates these countless data points into one unified picture. Through intelligent data fusion, the system combines inputs from multiple sources, for example, merging traffic data with weather updates and event schedules to predict congestion before it happens. For civil engineers, this revolution means infrastructure that communicates. Roads can tell when maintenance is needed. Pipelines can signal inefficiency. Buildings can adapt their energy use based on occupancy patterns. The digital metropolis thrives on this web of interconnected sensors, transforming static urban environments into dynamic, responsive systems that never stop learning. The neural network, understanding the AI algorithms processing this massive data stream. Visuals, inside a virtual AI brain, glowing neural pathways connecting city systems, with data flows forming synapses. If sensors are the eyes and ears of a smart city, then the neural network is its brain. This is where all the information, billions of data points streaming every second, is processed, analyzed, and turned into intelligent action. The city brain's neural network is modeled after the human mind. It uses layers of interconnected algorithms, known as artificial neural networks, and to detect patterns, make decisions, and continuously improve. These AI models process raw sensor data, identify trends, and translate complex information into actionable insights. For instance, convolutional neural networks (CNNs) are used in traffic cameras to recognize vehicle types, detect violations, or monitor pedestrian crossings. Recurrent neural networks are NNS, which understand sequences and time-based data, analyze traffic flow patterns to predict future congestion. Meanwhile, reinforcement learning, the same AI principle that powers robots, helps the city brain experiment and learn from outcomes, optimizing operations over time. Data from multiple sources, traffic sensors, environmental monitors, satellite imagery, and social media feeds are continuously filtered, cleaned, and normalized before being fed into these algorithms. The system learns correlations, like how rainfall impacts traffic speed or how temperature affects power demand. This neural layer doesn't just analyze, it learns. Every day, it becomes more accurate and efficient, refining its models based on real-world feedback. For example, if a traffic optimization plan fails to reduce congestion, the city brain remembers the outcome and avoids repeating the same mistake. Civil engineers now play a vital role in designing the physical infrastructure that supports this AI intelligence, from embedding sensor networks into roads and bridges to ensuring data reliability. Together, AI and engineering form a feedback ecosystem. Machines process insights, and engineers apply them in design and maintenance. In essence, the city brain's neural network acts as the city's collective intelligence, a powerful analytical engine transforming raw data into real-time decisions that make urban living smoother, safer, and more sustainable. Predictive power. Examples of the city brain anticipating needs before they become problems. Visuals. AI dashboard forecasting traffic, energy usage, and water flow. Emergency services responding instantly to AI alerts. Perhaps the most remarkable feature of an AI city brain is its predictive power, the ability to foresee issues before they occur and take action to prevent them. This predictive capability transforms cities from reactive systems into proactive organisms capable of self-optimization. Imagine a storm approaching. The city brain analyzes radar data, rainfall predictions, and drainage system capacity. Before the first drop of rain falls, it identifies flood-prone zones, redirects water pumps, and issues alerts to nearby residents. Traffic routes are automatically adjusted to prevent congestion in vulnerable areas. The city doesn't wait for problems, it prepares in advance. Similarly, in transportation, predictive analytics are revolutionizing urban mobility. Using data from GPS systems, surveillance cameras, and traffic sensors, the city brain can forecast congestion hours before it happens. It then adjusts traffic light sequences, updates navigation systems, and even coordinates public transport schedules. The result: smoother flow, lower emissions, and reduced travel time. In infrastructure maintenance, predictive modeling helps engineers detect structural fatigue in bridges or tunnels long before visible damage occurs. Machine learning models analyze vibration and stress data, identifying anomalies that signal potential issues. Maintenance can be scheduled proactively, preventing accidents and saving millions in repair costs. Energy management also benefits from predictive AI. By analyzing temperature forecasts and historical demand patterns, the system predicts electricity consumption peaks and reallocates power accordingly, ensuring balanced load distribution and avoiding blackouts. The same logic applies to waste collection, healthcare, and emergency response. Smart bins predict optimal collection times, hospitals prepare for likely patient surges, and emergency services position resources strategically based on AI forecasts. For civil engineers, this predictive intelligence changes the entire approach to planning and design. Instead of reacting to failures, engineers can now build infrastructure that anticipates them, designing systems that evolve over time. In short, predictive power is what transforms an ordinary smart city into a truly intelligent one. It is not just about knowing what is happening, it is about knowing what will happen and being ready for it before anyone else notices. Real-world impact, today's transformation, traffic mastery, real-time optimization of traffic lights, public transport, and emergency routes, visuals. Aerial footage of a busy city turning calm as AI traffic systems activate. Glowing roads, synchronized lights, emergency vehicles gliding through cleared lanes. In the heart of every city, traffic is the pulse that keeps life moving. But when that pulse becomes irregular with congestion, accidents, and delays, the entire system suffers. That's where the AI city brain proves its brilliance. It doesn't just monitor traffic, it manages and masters it. Through an integrated network of cameras, sensors, and connected vehicles, the AI city brain collects data from every intersection, highway, and transit hub. It processes real-time information on vehicle density, speed, and pedestrian movement, all within milliseconds. Using this data, AI algorithms dynamically adjust traffic light cycles to maintain smooth flow and minimize wait times. In Hangzhou, China, the City Brain platform developed by Alibaba Cloud reduced congestion by nearly 15% in its first phase. Traffic lights no longer follow rigid schedules. Instead, they communicate with one another like neurons in a living brain, creating adaptive, self-regulating traffic systems. Public transportation, too, benefits from this intelligence. Bus arrival times, train schedules, and passenger loads are constantly analyzed to optimize routes. If a major road becomes congested, the system automatically reroutes buses or dispatches additional vehicles on alternative paths, minimizing inconvenience for commuters. Emergency management is where this system truly shines. When an ambulance or fire truck is on call, the city brain identifies its route and clears the path by adjusting nearby traffic lights. In some cities, AI coordination has reduced emergency response times by up to 30%, potentially saving thousands of lives each year. For civil engineers, this means designing road networks that are not only physical corridors, but digital ecosystems. Highways become information highways, embedded with IoT sensors, adaptive lighting, and smart signage. The AI city brain transforms traffic from a chaotic challenge into a coordinated, intelligent symphony, where every movement, every signal, and every vehicle operates in seamless harmony. Resource efficiency, optimizing energy grids, water distribution, and waste management for sustainability, visuals, glowing smart grid maps, water systems dynamically rerouting, automated waste trucks navigating efficient paths. Modern cities consume enormous amounts of resources, energy, water, and materials. As populations grow, managing these systems efficiently becomes one of humanity's biggest engineering challenges. Enter the AI city brain, which acts as a master coordinator, ensuring that no drop, watt, or kilogram is wasted. Starting with energy, AI-driven smart grids monitor electricity production and consumption in real time. Sensors across power lines, substations, and smart meters feed data to predictive models that analyze demand fluctuations. When usage spikes, AI systems automatically redistribute loads, activate backup sources, or adjust renewable inputs from solar and wind farms. This balance prevents blackouts, reduces energy waste, and enhances grid reliability. In water management, AI optimizes supply and distribution through intelligent monitoring. Smart flow meters detect pressure drops and irregularities that might indicate leaks or unauthorized usage. Algorithms analyze weather forecasts and consumption patterns to predict future demand, ensuring that reservoirs and treatment plants operate efficiently. Some cities even use AI to manage stormwater systems, opening and closing drainage gates automatically during heavy rainfall to prevent urban flooding. Waste management has become equally intelligent. Smart bins fitted with ultrasonic sensors report fill levels to central servers. The AI brain then calculates the most efficient collection routes based on bin data, traffic conditions, and fuel consumption models. This optimization reduces operating costs and carbon emissions while maintaining cleaner public spaces. Together, these systems create what engineers call a circular city model, where resources are continuously reused, recycled, and redistributed. The city brain integrates sustainability into the city's nervous system, promoting eco-efficiency and resilience. For civil engineers, this is a major leap towards sustainable urban design. It requires understanding both the physical and digital dimensions of infrastructure, creating buildings that self-regulate energy, pipelines that self-diagnose, and cities that self-balance. In short, AI transforms resource management from a manual process into a living, learning system, ensuring smarter cities for a greener planet. Public safety enhancements, predictive policing, and rapid response systems in action. Visuals, AI control rooms, smart surveillance networks, emergency drones, and predictive crime heat maps. Public safety is the backbone of any thriving city. Traditional systems relied heavily on human response, police patrols, emergency dispatchers, and manual reporting. But the AI city brain takes public safety to a whole new level, introducing predictive intelligence that can prevent incidents before they occur. Through an interconnected web of surveillance cameras, acoustic sensors, and data feeds from social media, the city brain constantly monitors urban environments. It uses computer vision and machine learning to detect unusual activity, a stalled vehicle on a bridge, a crowd forming unexpectedly, or a sudden noise resembling an explosion. Once detected, it alerts authorities instantly, often before citizens even report the issue. Predictive policing models analyze years of crime data, identifying hotspots and patterns based on location, time, and social factors. Instead of random patrolling, law enforcement can now deploy resources strategically, focusing attention on areas where incidents are statistically more likely to occur. This data-driven approach enhances safety while optimizing manpower and budget efficiency. Emergency response coordination is also becoming faster and smarter. The city brain integrates fire, police, medical, and disaster management services into a single communication network. When an incident happens, say a fire outbreak, the system automatically identifies the nearest fire station, calculates the quickest route avoiding traffic, and adjusts nearby signals to ensure rapid arrival. Some cities are even testing drone-assisted emergency response, where autonomous drones equipped with cameras and first aid kits reach accident scenes before human responders. The AI system coordinates their flight paths, ensuring safety and efficiency. For civil engineers, this intelligence extends into the physical design of cities, from planning safer road layouts and resilient public spaces to integrating sensor-based monitoring into bridges, tunnels, and skyscrapers. AI-driven predictive models also help assess structural integrity after natural disasters, accelerating recovery efforts. The ultimate goal of these systems is not surveillance, it's safety through foresight. By blending AI prediction with engineering precision, the city brain transforms chaos into control, ensuring that tomorrow's cities are not just smarter, but safer, faster, and more humane. For tomorrow's urban fabric, a glimpse into the future, personalized city experiences. How AI might customize services for individual citizens. Visuals, futuristic cityscape glowing with data, citizens walking through streets where digital systems adapt in real time to their presence. Imagine waking up in a city that knows you, not in a surveillance sense, but in a way that genuinely improves your daily life. The traffic signals, street lights, and even public services are tuned to your personal needs. Welcome to the age of personalized urban experiences, powered by the intelligence of the AI city brain. In tomorrow's cities, personalization will redefine how we live, commute, and interact. The AI city brain will collect anonymized data from millions of citizens through wearables, smartphones, transport cards, and IoT devices. This information won't just improve infrastructure efficiency, it will tailor the entire urban experience to fit individual lifestyles. For instance, the city might predict your usual morning commute and adjust nearby traffic lights to ease congestion along your route. Public transport apps could synchronize with your schedule, ensuring your bus or metro arrives precisely when you reach the station. Street lighting could brighten automatically as you approach during night walks, powered by AI-driven motion sensors for comfort and safety. Healthcare services could also become proactive. AI might detect early signs of health anomalies from wearable devices and suggest nearby clinics or preventive programs. Educational platforms could recommend city events, workshops, or exhibitions relevant to your interests or profession. In the retail and leisure sectors, digital signage and public spaces could adapt dynamically, displaying personalized content or route suggestions based on crowd density and user preferences. For example, AI could recommend quieter cafes for work or greener walking routes for relaxation. For civil engineers, this vision means designing adaptive infrastructure, roads, parks, and transport systems embedded with sensors and responsive materials. These systems will interact seamlessly with AI algorithms, creating cities that feel alive and human-centered. Ultimately, the personalized city of the future isn't about technology dominating life. It's about technology understanding life. The AI city brain becomes not just a system of control, but a partner in creating smoother, safer, and more fulfilling urban experiences for every citizen. Autonomous everything. The integration of self-driving vehicles and delivery drones into a seamless system. Visuals. Autonomous cars gliding through smart intersections. delivery drones weaving between skyscrapers, AI control centers overseeing smooth urban mobility. As AI continues to evolve, the next major revolution in city life will be autonomy. Cities where everything moves intelligently on its own. The seamless integration of self-driving vehicles, autonomous delivery drones, and robotic logistics will redefine transportation, supply chains, and infrastructure. Self-driving vehicles will soon form the backbone of urban mobility, coordinated by the city brain. Fleets of autonomous cars, buses, and shuttles will communicate continuously with one another and with road infrastructure. Traffic lights will be obsolete, replaced by AI-managed intersections where vehicles glide through without stopping, maintaining perfect timing to avoid collisions. For civil engineers, this means a fundamental redesign of urban roads. Lanes may adapt dynamically to traffic density, and parking lots could transform into green spaces as private car ownership declines. Charging hubs for electric autonomous vehicles will be strategically positioned using predictive analytics to balance demand and minimize travel distance. Meanwhile, delivery drones and autonomous ground robots will handle logistics. From medical supplies to e-commerce packages, these systems will operate 24/7, guided by AI navigation models that analyze wind patterns, airspace conditions, and delivery urgency. Rooftops, balconies, and vertical corridors could evolve into drone ports, new architectural features integrated into building designs. This interconnected ecosystem will not only reduce congestion, but also minimize carbon emissions. Without human error, accidents will plummet and travel efficiency will soar. AI coordination ensures that every movement, from a food delivery to a public bus route, is part of a single, synchronized network. Smart cities like Dubai, Singapore, and Tokyo are already piloting autonomous fleets managed by centralized AI systems. In the near future, construction sites might also feature autonomous dump trucks, cranes, and surveying drones, blending robotics directly into civil engineering operations. Ultimately, autonomous everything represents the next stage in AI city evolution, where mobility becomes frictionless, logistics become invisible, and engineering transforms to accommodate intelligent movement. The city brain won't just control traffic, it will orchestrate motion itself, creating an urban ballet of precision, efficiency, and sustainability. Beyond infrastructure, AI's role in urban social planning and community building, visuals, diverse citizens interacting in digitally connected public spaces, AI data maps analyzing community well-being and sustainability. The true future of AI city brains goes far beyond roads, grids, or buildings. It lies in how technology can shape human relationships, fostering stronger, more connected communities through AI-driven social planning. Urban life has always been about people, their interactions, cultures, and shared spaces. Yet, as cities grow denser, maintaining social cohesion becomes harder. This is where AI can step in, not to replace human connection, but to enhance it intelligently. AI-powered urban analytics can study how people move, gather, and interact across neighborhoods. By analyzing mobility data, event participation, and demographic trends, the city brain helps planners design public spaces that naturally encourage community engagement. Parks, plazas, and pedestrian zones can be positioned based on behavioral insights, ensuring they serve real needs instead of abstract plans. For example, AI might detect that a neighborhood lacks recreational areas for children or has limited access to healthcare. Urban designers can then use this data to prioritize playgrounds or clinics in future developments. Similarly, community feedback gathered from digital platforms can be analyzed in real time, helping city planners respond quickly to local concerns. AI can also support inclusivity. By analyzing accessibility patterns, it ensures that transportation routes, sidewalks, and public facilities serve all age groups and physical abilities. Social AI models can even predict how new housing or infrastructure projects might affect property values, employment opportunities, and cultural diversity, allowing for more balanced urban growth. For civil engineers, this represents a holistic transformation. Designing a bridge or a metro line isn't just about physical strength anymore. It's about social connectivity. AI data helps engineers evaluate how infrastructure affects quality of life, mobility equity, and environmental well-being. In tomorrow's urban fabric, the city brain acts as both architect and sociologist, using intelligence to strengthen communities, reduce inequality, and ensure cities remain not only efficient, but also humane. The fusion of AI with social planning marks the dawn of cities that don't just function well. They feel alive, inclusive, and profoundly human. Challenges and the human element. Data privacy concerns, safeguarding citizen information in an increasingly monitored environment. Visuals, glowing data streams moving through a digital city, cameras on poles, and citizens surrounded by invisible data grids. As cities evolve into hyper-connected digital organisms, one truth becomes undeniable. Data is the lifeblood of the AI city brain. Every movement, click, and transaction generates information that helps the city think and act intelligently. But with this immense data collection comes one of the greatest modern challenges: privacy. In a smart metropolis, millions of sensors capture traffic flow, waste levels, air quality, and even energy consumption in real time. Cameras and IoT devices analyze crowd density, vehicle patterns, and emergency events. While this data drives efficiency, it can also reveal private aspects of citizens' lives if not properly protected. The line between smart and intrusive becomes dangerously thin. Who controls this information? How is it stored, used, or shared? Without strong safeguards, the same systems designed to serve could easily be exploited, leading to unauthorized surveillance, profiling, or even cyber attacks. To prevent this, cities must adopt a privacy by design framework. That means embedding encryption, anonymization, and data segmentation into every stage of collection and processing. Personal identifiers should be stripped before analysis, ensuring that no individual can be tracked or exposed. Access control systems, blockchain-based data validation, and transparent audit trails can further guarantee security and accountability. Civil engineers and planners must also collaborate with cybersecurity experts. When designing smart infrastructure, whether it's an intelligent bridge, traffic network, or waste system, data safety must be treated as a structural element, not an afterthought. On a policy level, governments must implement strict data governance laws, defining who owns the data and how it can be used. Citizens must be informed and empowered to opt in or out of certain data streams. Ultimately, the success of AI city brains depends not just on intelligence, but on trust. A city that respects the privacy of its people creates a foundation for innovation without fear, proving that smart cities can be both connected and conscientious. Ethical dilemmas, ensuring fairness, transparency, and accountability in AI decision-making. Visuals, digital holograms of justice scales balancing code and human figures, symbolizing ethics in AI governance. Every time an AI city brain decides how to route traffic, distribute resources, or prioritize emergencies, it makes a judgment that directly affects lives. But unlike humans, AI systems don't feel empathy. They calculate. This raises a critical question: can machines be fair, transparent, and accountable? AI models learn patterns from data, and data often reflects human biases. If the input data is skewed, the outcome will be too. For instance, an algorithm managing housing applications might unintentionally favor certain neighborhoods, or predictive policing systems might target specific areas based on biased historical data. In cities that depend on automation, such hidden biases can silently reinforce inequality. Transparency is another challenge. Many AI models, particularly deep neural networks, are black boxes. Their decision-making processes are complex and not easily interpretable. If a citizen's loan request is denied or their route is deprioritized during traffic optimization, how can they understand why? The lack of explainability threatens public trust. To overcome this, urban AI systems must be designed with ethical governance at their core. Governments and engineers must ensure every algorithm used in public infrastructure passes fairness audits, testing for bias, discrimination, and unintended harm. Explainable AI x AI should be integrated, allowing citizens and officials to see how conclusions were reached. Accountability mechanisms must also be established. When AI makes a mistake, a false prediction, or an unfair allocation, there must be a human oversight process capable of review and correction. Ethical boards consisting of technologists, legal experts, and community representatives can act as watchdogs for AI-driven policies. In the future, ethical engineering will become as important as structural integrity. Just as a bridge must be safe under load, an AI system must be morally balanced under pressure. The smartest cities want to be those that process data fastest. They lines be the ones that do it fairest. The human role. How citizens and urban planners will collaborate with these intelligent systems, visuals, engineers, city planners, and citizens interacting with holographic 3D maps and AI interfaces. As cities become more intelligent, one truth must remain clear: the human element can never disappear. The city brain may calculate, analyze, and predict, but it is humans who define its purpose. The future of AI-driven cities depends on collaboration between citizens, engineers, and the intelligent systems that guide them. Urban planners of the future won't simply design roads or utilities. They lines co-design with AI. Using predictive modeling, planners can simulate urban growth, test environmental impacts, and evaluate social outcomes before construction begins. But these decisions must always reflect human priorities, equity, culture, and well-being, not just computational efficiency. Citizens, too, play a vital role. Through participatory platforms and digital feedback channels, residents will continuously interact with the city brain, reporting issues, suggesting improvements, and shaping neighborhood development. AI will act as an amplifier of public voice, not a replacement for it. In emergency management, this partnership becomes even more crucial. AI can forecast floods, traffic jams, or energy shortages, but it's humans who implement solutions on the ground, ensuring compassion and adaptability in every response. Civil engineers, architects, and data scientists must embrace interdisciplinary collaboration. Tomorrow's infrastructure teams will blend technical expertise with social understanding, ensuring technology aligns with community values. The city brain will assist, not dominate, providing insights, optimizing plans, and supporting sustainable development. Education also plays a pivotal role. Future citizens must be data literate, aware of how AI influences their lives, and empowered to question or guide it responsibly. Cities will thrive only when their people understand the systems that serve them. In essence, the human role in AI cities isn't shrinking, it's evolving. We are no longer just users of the city, we are co-creators of its intelligence. The city brain may think, but humanity must always decide. Together, man and machine can build cities that are not just smart, but wise, empathetic, and deeply human at their core. The rise of AI city brains marks a new chapter in human civilization, one where cities don't just exist, but think with us. From smarter infrastructure to ethical innovation, this transformation challenges engineers, planners, and citizens alike to dream bigger and build wiser. As we step into this intelligent age, our responsibility grows to ensure technology serves humanity, not the other way around. The future of cities is being written today, and every one of us holds the pen. Stay tuned with Civil Engineering Edge, where we build knowledge for tomorrow's world.